Our story begins in an unimaginable abyss of time. It starts not with a gentle dawn, but in the swirling chaos of a stellar nursery. Imagine a vast, dark cloud of gas and dust adrift in the Milky Way. This was the Solar Nebula, the birthplace of stars and worlds. Some 4.6 billion years ago, a nearby star may have exploded, sending a shockwave rippling through this cloud. This cosmic nudge was all it took. Gravity, the silent architect of the universe, began its patient work. It pulled the dust and gas inwards, spinning it faster and faster into a flattened, glowing disk. At its heart, a new star, our sun, ignited. Out in the swirling disk, tiny grains of dust began to stick together. These clumps, through countless gentle collisions, grew into pebbles, then boulders, then planetesimals. Our Earth was not born fully formed. It was assembled piece by piece in a violent, chaotic dance. These planetesimals crashed into one another, merging in cataclysmic impacts. Each collision added mass and, crucially, immense heat. Our world was not a serene blue marble then, but a glowing, molten sphere of liquid rock. One of the most significant of these collisions involved a Mars-sized object which we call Theia. The impact was staggering. It struck a glancing blow, vaporizing vast portions of both bodies and flinging a colossal plume of molten rock into orbit. This debris eventually coalesced to form our constant companion, the Moon. In its infancy, the Earth was a truly alien world. Its surface was a hellish landscape, a roiling ocean of magma beneath a sky choked with toxic gases. There was no blue sky, no white clouds, only a thick, oppressive shroud of carbon dioxide, water vapor, and nitrogen. Volcanoes were everywhere. High in the upper atmosphere, something remarkable was happening. Water vapor molecules were being split apart by the intense ultraviolet radiation from the young sun. The lighter hydrogen atoms escaped into space, but the heavier oxygen atoms remained. Some combined to form ozone, slowly creating a fragile shield that would one day protect life. As the planet gradually cooled, it reached a tipping point. The temperature dropped below the boiling point of water. And then, the rains began. It was a deluge of biblical proportions. Where did all this water come from? While volcanoes provided some from the planet's interior, another source was the cosmos itself, icy comets rich in frozen water. As the rains fell, water pooled in the lowest areas. Trickles became rivers, rivers carved canyons, and canyons emptied into vast basins. The first oceans began to form. These new oceans began to act as a global thermostat, stabilizing the planet's temperature. The stage was now perfectly set for the most miraculous act, the dawn of life itself. For 1 billion years, the young oceans were a chemical soup, rich in dissolved minerals and organic molecules, bathed in energy from volcanic vents and lightning. In this primordial broth, simple organic molecules began to link together. Eventually, one developed the ability to make copies of itself. This was the dawn of life. Around 2.7 billion years ago, cyanobacteria emerged with a revolutionary trick: photosynthesis. They could harness sunlight to create food but had a toxic waste product: oxygen. For hundreds of millions of years, this oxygen reacted with iron in the oceans, causing it to rust and settle. But eventually the iron was used up, and oxygen entered the atmosphere. This triggered the Great Oxygenation Event, the planet's first extinction caused by life itself. Oxygen was poisonous to anaerobic microbes that had dominated for eons. The rising oxygen paved the way for complex life forms that could harness its powerful metabolic energy. The sky began to clear and turn blue. The world was being terraformed by its smallest inhabitants. Around 541 million years ago, something spectacular happened. In a geological blink of an eye, the ocean suddenly came alive with complex multicellular animals. This was the Cambrian explosion. For the first time, we see creatures with shells, legs, exoskeletons, and distinct heads and tails. There was the fearsome Anomalocaris, the armored Wiwaxia, and the trilobites with their complex eyes. Nearly every major animal body plan that exists today made its first appearance during this incredible period. What caused this burst? Scientists believe it was a perfect storm of conditions: rising oxygen levels, the end of snowball Earth, and crucially the evolution of predation ignited an evolutionary arms race. Animals developed defenses while predators evolved better hunting abilities. For 3 billion years, life was confined to water. The land was barren and hostile. But around 470 million years ago, descendants of green algae began colonizing the damp edges of the land. Plants faced enormous challenges, supporting themselves against gravity, absorbing nutrients, and preventing dehydration. They evolved rigid stems, vascular tissues, and waxy cuticles. As plants conquered the land, they created new habitats. The first land animals were arthropods, millipedes, scorpions, and spiders, already equipped with supportive exoskeletons. Soon after, the first vertebrates crawled ashore. Fish like Tiktaalik, with its limb-like fins, could prop itself up and venture onto land. These were the ancestors of all land vertebrates, including us. The Carboniferous period was the age of coal forests. The climate was warm and humid, and vast swampy forests covered the globe. Plant life flourished on an unprecedented scale. When these giants died, they were buried and compressed, forming coal seams. The oxygen-rich air allowed insects to grow enormous, like Meganeura with the wingspan of a seagull. Life's journey has been punctuated by catastrophic mass extinctions. The most devastating occurred 252 million years ago, the Great Dying, likely caused by colossal volcanic eruptions in Siberia. This triggered runaway global warming, ocean acidification, and oxygen loss. Over 95% of marine species and 70% of land vertebrates vanished forever. It took millions of years to recover. From this devastation, new life rose. The extinction cleared the slate, creating opportunity for reptiles to dominate. This was the dawn of the Mesozoic era, the age of reptiles and dinosaurs. For 180 million years, dinosaurs were Earth's masters. They diversified into an astonishing array, from colossal sauropods like Argentinosaurus to fearsome theropods like Tyrannosaurus rex. During this time, our mammalian ancestors were small, nocturnal creatures living in the shadows, their potential held in check by the reigning dinosaurs. Then, 66 million years ago, their reign ended abruptly. A 6-mile-wide asteroid slammed into Earth, unleashing the energy of billions of nuclear bombs and triggering global catastrophe. With the dinosaurs gone, the world was open for new rulers. Surviving mammals, small and adaptable, emerged into a transformed world. This began the Cenozoic era, the age of mammals. Among evolving mammals were primates that took to trees. Climate change created savannas, prompting one lineage to walk upright. These early hominins were the first steps toward humanity. Finally, 300,000 years ago, Homo sapiens evolved with larger brains, complex language, and symbolic thought. We spread across every continent, eventually becoming a global species. 12,000 years ago, we invented agriculture, leading to civilizations and explosive population growth, setting the stage for industrial and digital ages that have reshaped the planet. In Earth's vast 4.5 billion-year saga, our chapter is but the last word. Yet we've become the most powerful force for change, but this rapid ascent has come at tremendous cost. Our appetite for fossil fuels is altering the climate system. The evidence is written in melting ice and rising seas. We're pumping CO2 faster than Permian volcanoes, acidifying oceans and threatening coral reefs. We're presiding over Earth's 6th mass extinction. Deforestation, pollution, and habitat destruction are driving species extinct at rates not seen since the asteroid that killed dinosaurs. The rich tapestry of life, woven over hundreds of millions of years, is being unraveled. From pollinating insects to great whales, every loss diminishes planetary health and stability. We stand at a profound crossroads. One path leads to sustainability, where we use intelligence and technology to live in balance with nature. We could harness clean energy, restore forests and oceans, and protect biodiversity. The other path continues current destruction, leading to ecological collapse and climate chaos. The choice is ours. Earth has endured cataclysms far greater than us, and will survive. The question is, will we? The lessons from our planet's epic journey are clear. Change is constant, life is resilient, but the conditions that support us are fragile. Our survival depends on our wisdom.